Okay, so to pick up where we left off for 1993, B, so you're doing your setup, you're taking your molarity times your volume to get moles. And then once you do that, you're gonna take this answer, you're gonna plug it in here because you found out that there's a 1-to-4 relationship there. And so that's how you're gonna solve for part B. And if you do it correctly, the answer should be 1.36 times 10 to the negative 5th moles of oxygen. Okay, so C is asking you, how would this result in B be affected if some I2 were lost before the S2O3 2- was added? So if you go back and you look at that previous equation and you look at the I2, or the iodine ion, the I2, it is a product in the second equation. Everybody see that I2 aqueous solution is a product. And then in the next one, it's a reactant for the third equation. And so if we lost some before the third equation happened, that's gonna change our amount. We're gonna have less of it. And since we have less of it, that means we're gonna be able to make less of our products. So that I2 might be our limiting reactant in that case. And so it's going to make us have less of our products. And so the way the question asks us, it says, how will the results in B be affected if some I2 were lost before the S2O3 was added? Explain. And so the answer says less I2, therefore less S2O3 required, therefore a lower amount of O2, both direction and reason required. So hopefully that makes sense that you're losing that I2, and so to react all the way, you'll use less S2O3 to react with it, and you'll make less product. But since we need less thiosulfate, it goes back and it changes that mole-to-mole ratio with the oxygen as well. And so all of that is needed to be included for part C. And then we have, what volume of dry O2 measured at 25 degrees Celsius and 1 atmosphere pressure would have to be dissolved in 1 liter of pure water in order to prepare a solution of the same concentration as that obtained in B. So we want our concentration to be that as of obtained in B, which we said was, B was the 1.5, I believe, let's look and see. B is 1.36 times 10 to the negative 5th moles is our molar concentration of oxygen, and it wants to know the amount. So what volume? So we're looking for V. So what volume? Looking for V of O2. Measure it at 25. So I know my temperature, which remember 25 is in Celsius, and we want it to be in Kelvin. So you're going to add 273, which gives us 298 Kelvin. And then it says my atmosphere, so my my pressure is 1 atmosphere. And then it tells me like to be dissolved in 1 liter. So I do know my volume. My volume is 1 liter. And, oh no, never mind. It's dissolved in 1 liter of pure water. I should read the rest of the way. So I'm still looking for my volume. 1 liter of pure water in order to prepare a solution of the same concentration as that obtained in B. And so we know our moles. So N is moles. So we're plugging into Pivnert to solve for that B volume of oxygen required, and it wants it to be the same concentration from B. So if we go back and look at B, it tells us the concentration of the sodium thiosulfate. So if we can make our oxygen the same molarity, and we have to go back and think about the total volume. And so we're going to take this moles, we're going to divide it by the total volume, and then we can set up a proportion. And so if we go here, so as I'm looking, the total volume was 50 milliliters of water. Which is it's 0.05 liters. So I'm going to take this molar, to get the molarity that I'm looking for, the molarity that they're asking us for, I'm going to take 1.36 times 10 to the negative 5th. I'm going to divide it by 0.05 liters. I do that because in part B, it says it was dissolved in 0.05 liters of water. And so that's where we're getting that solution from. And this is gonna give us our molarity we're looking for. And so when we plug in, we're going to use, instead of using this molarity or this mole for Pivnert, we're gonna use whatever this concentration is because our volume is gonna be 1 liter. So we want X up above. So hopefully this is making sense. So you plug into Pivnert. When you plug into Pivnert to solve your molar concentration, so this molar concentration is equal to 2.72 times 10 to the -4th. And that's moles per liter. So if we have 1 liter, then we want that many moles. So I want this to equal 2.72 times 10 to the -4th. So to do that, that's what I'm gonna use to plug in. So my N is gonna be 2.72 times 10 to the -4th moles. So when I plug into Pivnert, all of these things, because remember R is a constant, so when I plug in with all those things, R's are constant, then I should solve and you should get 6.65 milliliters. And that it seems like, nope, there's one more part E. Name an appropriate indicator for the reaction shown in equation 3 and describe the change you would observe at the end point of the titration. So there's some indicators that are always good. And so you could have said, like, for this one, you would have to know a little bit more about titration. So that last part's super hard. But the ones that they're looking for is like a starch indicator. You also could have said something like, they don't want just color change alone, it's not sufficient, and any other color with starch is not sufficient. So they're really just wanting a starch indicator, it looks like. But we'll talk about indicators later.